Good morning, everyone. A very good morning. Shall we begin? Yeah, today's topic is the ER model. In the last class, we have finished what is the database design, how it is accomplished. Now, next topic is what is the ER model, how we are using the ER model, who developed the ER model, what are the various benefits of ER model, what are the entities, what are the relationship. That is the ER model. Okay. So this ER model was developed to facilitate the database design by allowing the specification of an enterprise schema that represents the overall logical structure of the database. So whenever we are whenever we are dealing with the specification of an enterprise schema that represents the overall logical structure, this ER model is very useful in mapping the meanings and interaction of the real-world enterprises onto a conceptual schema. And because of this usefulness, many database design tools draws on the concept from the ER model. So full form is entity relationship model. As a name advice, okay. So wait for 10 minutes or 5 minutes. All right. So this was developed to facilitate the database design by allowing the specification of an enterprise schema that represents the overall logical structure of the database. And this model is very useful in mapping the meanings and interaction of the real-world enterprises onto a conceptual schema. And because of this usefulness, many database design tools draws on concept from the ER model. And this or the ER data model employ three basic concepts: entity sets, relationship sets, attributes. So there are three basic steps in the ER model. One is the entity set, one is the relationship set, one is the attribute. So ER model has a associated diagrammatic representation with the ER diagram that we study also in the this ER diagram or ER model. Okay, so let's talk about the first one, that is the entity set. So entity is anything or object in the real world that is differentiable from all other objects. For example, if I'm talking about a person, that may be a student, that may be a teacher, that may be anyone. So each person in university is an entity that may be established, that may be used. An entity have a set of the properties that is known as the attributes also. So that attributes and the values that forms a set of the properties that may uniquely identify as an entity. So each person in a university is an entity. An entity has a set of the properties and the values. So some of the properties may uniquely identify an entity. For example, if I'm talking about a student, there's a student ID, student roll number. That is a unique identity. That is an entity set. For example, a person may have a person ID. That is the same example property whose value uniquely identify that person. Therefore, the value when we talk about the 677, 678 or 89 for the person ID would uniquely identify one particular person in the university. Similarly, the courses that can be thought of as entities, course ID that uniquely identifies the course entity in the university. An entity may be concrete, such as a person or the book, or it may have an abstract, such as a course offering, flight reservation. And this entity set is the set of the entities of the same type that share the same properties or the attributes. And the set of all the peoples who are the instructors at the university, for example, can be defined as the entity set instructor. Similarly, when we talk about the student, that might represent the set of all the students in the university. And in the process of modeling, we often use the term entity set in the abstract without referring to a particular set of the individual entities. So we use the term extension of the entity that set to the or refers to the actual collection of the entity belonging to the entity set. Therefore, the set of the actual instructors in the university forms a extension of the entity set instructor also. That do not need to be disjoint. For example, it is also possible to define the entity sets of all the people in university. That may be a person. The person entity may be an instructor entity, that may be a student entity, or both, or neither. Now, this or each and every entity is represented by a set of the attributes. The attributes are descriptive properties possessed by each member of entity sets, and the designation of attributes for entity sets expresses that the database stores similar information concerning each entity in the entity set. However, each entity may have its own value for each attributes. However, it is also used with the possible attributes of the instructor entity set that have the ID, name, department name, and the salary. And in the real life also, there would be further attributes such as the street number, apartment number, that is the real time life entities. Street number, apartment number, state, postal code, country, but we omit them to keep our example simple. And the possible attributes of the course entity sets are the course ID, title, department name, and the credits. And when you talk about the entity that has a value for each of its attributes, for example, a particular instructor entity may have the value 12121 for the ID, value WU for the name, value finance for the department name, and the 90,000 for the salary. So there are multiple fields, multiple values, multiple departments that will be used the particular instructor entity. And the ID attributes is used to identify the instructors. Uniquely, is there may be more than one instructor with the same name. And in the United States, many enterprises find it very convenient to use the social security number of a person as an attribute. And when we talk about the database, that includes a collection of the entity sets, each of which contains any number of the entities of the same type. So that includes a number of the other entity sets also. For example, in addition to keeping the track of the instructors and the student, the university also has information about the courses which are represented by the entity set course. That course may be with the attributes course ID, title, department name, credits. And in the real settings, we say that the university database can keep dozen of the entities. Next is the relationship, that is an association among the several entity. For example, we can define a relationship advisor that associates the instructor cards with the student chunk. This relationship is maintained with the person with the student. So it is a set of the relationship of the same type, different types, and probably it is represented on the relation n greater than or equals to 2. Now consider the two entity sets, instructor and the student. So we defined a relationship set advisor to denote the association between the instructor and the students. As another example, consider the two entity sets, student and the section. So we can define the relationship set takes to denote the association between the student and the course. Section in which the student is enrolled. That is participate in the relationship set R. And this instance ES schema represent an association between the name entities. As an example, when it's about the cats that are ID 45565 and the student entity Shankar who has ID 12345. Participate in a relationship instead of the advisor. This represents that the university CATS is advising the student. So what is the relationship that is advising? The function that an entity plays in a relationship is known as the entity role. So a relationship may have multiple attributes also that are known as a descriptive attributes. So consider relations at advisor with the entity sites instructor and the student. So we could associate the attribute date with that relationship to specify the date when an instructor becomes advisor of a student. And the advisor relationship among the entity corresponding to instructor cards and the student Shankar has a value 10 June 2010 with the attribute date, which means that the cards became Shankar's advisor on the 10th June 2007. Now this is the figure that represents the relationship between the date and the advisor. So this is the date, this is the name, this is the date, this is the name. So this is the advisor name, this is the name, date, this is the date, this is also the date. That becomes the advisor for the date. So as an example of the descriptive attribute of the relationship, consider the entity sets, student in the section which participates in the relation set takes. You may take to store a descriptive attribute grade with the relationship to record the grade that a student got in the class. So we may also store a descriptive attributes for the credit to record whether a student has taken the course for the credit or is auditing or sitting in that course. A relationship instance in a given relationship set must be uniquely identifiable from its participating entity without using the descriptive attributes. So to understand this point, suppose we want to model all the dates when an instructor uses or becomes advisor of a particular student. The single valued attribute date can be stores a single date only. That can be expressed or represented with the multiple dates by the multiple relations between the same instructor or the student. And since the relationship instances would not be uniquely identifiable using only the participating entities. So the right way to handle this case is to create a multi-valued attribute date which can store all the dates. It is also possible to have more than one relationship set involving the same entity sets. In our example, the instructor set student entity participated in the relationship set advisor. Additionally, suppose each student must have another instructor which serves as the department advisor, and the instructor and the student entity sets may participate in another entity relationship set, that is the department advisor. There are two relationship sets, that is the advisor and the department advisor, that provides examples of the binary set relation that involves with the two entity sets. And most of the relationship sets in the database system are the binary one. And occasionally, however, relationship sets involves more than two entity sets also. That is occasionally. And as an example, suppose that we have an entity set project that represents a research project carried out in the university. So consider the entity sets instructor student project that have multiple associated students or the instructors. So represent this information, we relate these three entity sets through the relationship that is a set project guide, which indicate that a particular student is guided by a particular instructor on a particular project. And the number of entity sets that participates in a relationship is a degree of the relationship. So whatever the entity sets we are representing, that is a degree. For example, when I talk about the binary relationship, that is the two values, only 0 and the 1, so that have a degree 2. Ternary relationship, that is a degree 3. Now, what is the meaning of attribute? So for each attribute, there is a set of permitted values known as a domain or the value set of that attribute. And the domain of attribute course ID might be the set of all the text string of a certain length. Similarly, the domain of an attribute semester might be a string from the set that is the fall, winter, spring, or the summer. And formally, an attribute of an entity set is a function that maps from the entity set into the domain. That may have several attributes. Each entity can be described with a set of the attributes data values pairs and one pair for the each attributes of entity sets. For example, when you talk about a particular instructor entity, that may be described by the set ID 76766, name, Crick, department name, biology. That meaning that the entity describes a person named Craig whose instructor ID is 76766, who is also a member of the biology department with a salary of 72,000 dollars. And we can see at this point it is an integration of an abstract schema with the actual enterprise being modeled. And the attribute values describing an entity constitutes a significant portion of the data stored in the database. And whatever the attribute that is used in the ER model, that can be characterized by the following attribute types. One is the simple and the composite attributes. And the composite attributes is further also divided into the subparts. For example, when you say about the name, that may be divided into three parts: first name, middle name, and the last name. In the same way, when we talk about the address, that includes the attribute street, city, state, zip code. Next is single valued and the multi-valued. So some entities may have a single values. We can say that some attributes have a single value, some attributes have a multiple value. So entity sets or student entity refers to only one student ID. That is known as a single valued. When you talk about the student name, there may be a last name, there may be a first name, there may be a first, last, and the middle name. That is an example of the multi-valued attribute. This is a name, composite attribute, first name, middle name, last name, address, component attribute, street number, street name, apartment name. That is also further divided of the or division of the street. An instructor may have a 0, 1 or several phone numbers, and different instructors may have a different number of the phones that may be denoted or that may be known as the multi-valued. Next is derived attribute. So value for this type of attribute can be derived from the value of the other related attributes of the entities. For example, let us say that the instructor entity set has attribute students advice, which represents how many students an instructor advises. So we can derive the value for this attribute by counting the number of the students entity associated with that instructor. And as an example, suppose that the instructor entity set has attributes age that indicates the instructor age. That entity set also have an attribute date of birth, and we can then calculate age from date of birth and the current age. this age is derived attribute because it is derived from the date of birth and the current date. An attribute also takes a null value sometimes. Sometimes it takes a null value when an entity does not have a value for it. So null value may indicate not applicable. That is NA. That is when that the value does not exist for the entity. For example, one may have no middle name. So null value can be assigned with that attribute value that is unknown. And unknown value may be either missing, maybe either not. The value does not exist, but we do not have that information. Or not known, we do not know whether or not the value actually exists or not. For example, if the name value for a particular instructor is null, we assume that the value is missing since every instructor must have a name. Because each and every instructor must have a name, so we assume. And a null value for an apartment number attribute could mean that the address does not include an apartment number. That an apartment number exists, but we do not what is missing, or that we do not whether or not apartment number is a part of a instructor department or not. The next is the constraint. So here enterprises schema may define certain constraint to which the contents of a database must conform. In this section, we examine mapping cardinality and the participation constraints. So we use the mapping cardinalities or cardinality ratio express the number of the entities to which the another entity can be associated by a relationship set. So whenever we are using the relationship sets, that relationship sets will be combined with the entity sets that will be combined with the mapping criteria. So that may be a constraint, that may be an entity set, that may be describing the binary relationship sets. So there may be a multiple relationship sets. One is one-to-one, then one-to-many, then many-to-many, many-to-one. The next is the keys that we also discuss about that primary key, foreign key, the candidate key. We have discussed about this. Then next is the ER diagrams. That is or ER model. That is a diagram how to combine or how to make the ER models. That is the ER diagram. So yes, when we talk about the constraints, or when I talk about the how to remove the redundant attributes. So when we design a database using the ER model, we usually start by identifying those entity sets that should be included. For example, in the university organization, we have discussed thus far, we decided to include such entity set as a student, instructor, and so on. And once the entity sets are decided upon, we must choose the appropriate attributes. And these attributes are supposed to represent various values that we want to capture in the database. And the university example or organization, we decided that for the instructor entity set, we will include the attributes ID, name, department name, and the salary. And we could have added the attributes for number, office number, home page, and so on. And the choice of what attributes to include is up to the designer who has a good understanding of the structure of the enterprise. So to illustrate, consider the entity set, that is the instructor and the department. There are two instructors. So entity set instructor includes attributes ID, name, department name, salary, with the ID that forming the primary key. The entity set department that includes attribute department name, building budget, with the department name forming the primary key. So one is ID that forms the primary key, one is the department name that also forms the primary key in case of the department table. A department name appears in both the entity sets. So since it's the primary key for the entity set department, so it is also redundant in the entity set. Redundant means duplicate in the entity set, that is either the instructor and needs to be removed. In this case, there is a need for the removing the attribute because it is very much important to remove the redundant data, because when we include the duplicate data, there is not the wastage of the memory, but also wastage the resources. Everything is going to waste because same thing is repeated out many times. It's better to remove that place. So, similarly, when we say about the student's entity set, that is also related to department entity set. So the relationship set department or student department, and thus there is no need for the department name and attribute in the student. As another example, consider about the offering, course offering sections along with the timing slot of the offering. So each time slot is identified by the time slot ID.